Ready? So this is the original problem. The original problem says if 8 does not divide, that's how you read that. If 8 does not divide a squared minus 1 for whatever value of a, then a must be even. So again, we use contrapositive. It suffices to show that, then you do the negation of this, implied negation of this. We remember that. So, which means we want to show that if a is odd, then 8 divides this. And the meaning of 8 divides this is that this is a multiple of 8. So if you are able to express this a squared minus 1 in this form, you are good to go. For some y in z, y is any integer. Okay? So again, we start with the hypothesis. Now this is your new hypothesis. Okay? Or should I say antecedent? So this is antecedent and this is what? Remember the word? Antecedent and the if part is the antecedent. The then part is the what? Don't think about it. She's trying to open some notes. Antecedent and consequence. Antecedent and consequence. Anyway, so from the antecedent, we can write a in this form because we assume a is odd. Then we are trying to justify the consequence. The consequence is that a squared minus 1 must be in this form. So we start by expressing a squared minus 1. And you get this. What I did here was difference of two squares. So if this is p squared minus q squared, then we can have p plus q and p minus q. You don't have to write in this form. Of course, many of you did the normal expansion. That's fine. Eventually, I got this, which you wrote as this when you did it. So which is fine. So it means our a squared minus 1 is this. That's okay. So the problem that many of us had from this point is, how do I make this 8 times something? Okay? Which everybody should understand why it is a problem. You can't just look at this and assume you can get a 2 out of it. But there's a way we can go about it. We already said at the beginning that k is an integer. So there are two possibilities. We solve the two of them. And this is now using proof by exhaustion technique under proof by contrapositive. So you do, you combine all these are like tools. Nobody tells you when you need them. It's like having them in your pocket, ready-made. So you get somewhere, you need your screwdriver, you bring it out, you tell, oh, I'm using my screwdriver now. Okay? Something like that. So use proof by exhaustion because we know there are just 2 possibilities. Even if you have 3 possibilities, of course you do it. A number, an integer can either be odd or even. Nothing more. If this is odd, we know that the square of any odd number is also an odd number. And we know that the sum of 2 odd numbers must be even. Which means this k squared plus k can be written in this form. This is the format of all even numbers for some integer t. So, for the first possibilities, we are good. For the second possibility, why are we doing this? We are trying to achieve 4 times 2 times something. This is what we are trying to achieve. So the moment we are able to express this bracket as 2 times whatever, we are good. That's the whole idea. So for the first possibility, we have our 2t, which we need, the extras. For the second possibility, if k is even, k squared must be even, because of course we know the square of any even number is an even number, right? Even integer. Then the sum of 2 even is also even, which means this can be written in this form for some. You can see that I use different variables, because it doesn't have to be the same t in the 2 cases. I can use different variable. So which means eventually what we are trying to do here can now be written in this form. Which means we now have it in terms of our 8d, which is the original goal. Okay, now we can conclude that 8 indeed divides it. Then I try to recall the original statement. If the contrapositive has been proved, then the original statement is true because these two are equivalent. Okay? Now the last one was 27 question. I just want to explain the trick that we use here. If anybody is confused later when you're doing it. The original question says x and y are real numbers. And if y cubed plus y x squared is less than or equal to this, then y must be less than or equal to x, isn't it? Then we try to arrange the contrapositive. The contrapositive will be this. If you're able to show this, then we are good, right? So, it's easy. I try to use a cheat. Look at this very well. It's factorizable. This is the goal. It's factorizable. If y comes out of this, you get y squared plus x squared. So it's sum of squares of x and y, basically, being multiplied. If you check this, you get the same x squared plus y squared. They are arranged in different order. I need your attention, please. Now, since we know they are real numbers, we know we are going to eventually multiply to both sides. But you have to be careful. When you multiply a term to both sides, like I said, you must be able to justify why the sign does not change. Okay? You are trying to multiply both sides of this with something. If whatever you are multiplying could be positive or negative, you can't just conclude. What you are doing is for all situations. You must be able to tell us the only situation we have is positive. That is the reason you have to explain in this form. Okay? Since x and y are real numbers, and we know that one is greater than the other, so even if one of them is 0, the other is not 0, which means we have one of the squares not to be 0. At least one of the squares, which means some of the squares can never be 0, must always be positive. Do you get the point? Okay? So that is the reason we are free or clear to multiply both sides to negative. Then the rest will follow. Does it make sense? So if anybody needs to use this as a review later, there we have it. Okay? Can we pause that?